Hello, I'm Anna Mackay, and this video is on function notation. What is that? So we're used to writing equations of graphs as y equals, and the new terminology here is f of x. So that reads f of x is how we pronounce that. How is this useful? So for example, if we had this function, in the past you're used to seeing that as y equals 2x plus 1, so that you understand that whatever x coordinate you put in there, the resulting answer that you'll get is your y coordinate. It's still exactly the same concept. So what you get for your f of x value is going to be your y coordinate when you come to graph this function. So here, where we have the f bracket, and we did have an x, and now we have substituted x for a 0. And so that's telling us that where you see x, you're going to substitute in 0 into the function to see what you get. So we would have 2 bracket 0 close bracket plus 1. Now, point here, always use brackets when substituting x values. Have you got any thoughts as to why that might be important? Well, it's so it will avoid problems with negative values. We're going to do a few examples later down the track where you can see when you start to have double negatives, how you've got to be really careful with those. Okay, so that comes out to be where we had a x, we substituted in 0, that becomes 0 there, add 1, so so we're just ending with 1. Whoops-a-daisy. Moving on, if we substituted in 1, we would have, what would we have? Where you see an x, you put in a 1, get into the habit of using brackets, working that out, we would get 3. Now, at year 11 level, you can start to get into the habit of these simple ones. If you can do those in your head, you can just jump to the answer. But it's not a bad habit to get into the practice of doing some of the setting out each time. This is preparing you for harder stuff in year 11 and year 12. If you ever have to backtrack and find your error, it's very handy to have some steps of working out seen there to help you backtrack and find the spot where that error happened. If you skip lots of steps, it's going to be very hard to work out what you were thinking at any point in time. Just a tip there. If we had to substitute in -2, same thing applies, put in brackets, we're having 2 multiplied by -2, add 1 to give us -3. All right, what does this look like as a graph? So our first point here, we see f of 0 equals 1. So in this position here was the x coordinate, and the answer on the right hand side is actually our y coordinate. The reason I really like function notation is in this one equation there, you have your x and your y coordinate sitting there. Really easy for you to see. You don't have to backtrack and see what was my x coordinate again that I substituted in. They're sitting there together. And conveniently they read in order. Just like x and y appear, x is first, y is second. Here, the 0 appears first and then the 1 appears second. So it's really neat and tidy. Graphing that, x is 0 here, up to y is 1. Looking at each of those points there, we have the coordinate 1, 3, and that's graphed, and then the coordinate -2, -3. And so they create our function of 2x add 1. Good. Having a think about this wording, try and get your head into this sort of thinking. F is the function that converts 0 into what? When you had 0 for x, it converted it into 1. There we go. So this is the rule. This f function is the rule for these x values. Next one, f is the function that converts 1 into 3. F is the function that converts -2. So when x is -2, it turns it into -3. So they are 3 specific x values. What about f is the function that converts x into what? So how did we get each of the corresponding y values, if you like, the function values? Well, we used the function, and so that's the answer that we're after here. f is the function that converts x into this answer. So it's the set of rules, if you like, that we're applying to x each time. And so the technical definition of that is f of x. F is the function that converts x into f of x. Just get used to interchanging f of x and y. They're interchangeable. Okay, so this function can be written as this. Let's have a talk through what each of these bits mean. The f reads the function, so function f. The two dots here mean such that, so you're telling your reader what to do with the function. And this reads such that x is converted into 2x plus 1. So it's sometimes referred to as the mapping of the x in this case. All right, let's get into some examples. If our function is this, 5 subtract x squared, find f of z. All that's telling us is having that z there is where we see an x, because that's how the function was, we're going to substitute in a z. We substituted in numbers before, this time we're substituting in a z. This is getting practice for some slightly harder ones. So you write out your function, and where you see an x, you're now putting in a z. So you can see the neat translation there, if you like, and then we use our mathematical etiquette and put it in descending powers. So the squared to the power of 1 and then the constant term at the end. What if now we're asked to substitute in negative x? So the function here for negative x. So you go along. Now it was subtract x, hence why the brackets come in really handy here. So because we're going to end up with a positive down the track, as you can see. Really important with the square. It's so common for people to just write things like, well, this would be, well, I'm not even sure, because you could possibly think about, oh, there's double negatives, I'll just do that. Actually, that's not such a problem there, is it? Well, or is it? Think about what's happening to the square. Now remember, the error one that I wrote down before was this. People see, oh, I've got a negative here, I'm putting in a negative x, oh, they must become a positive, so I'm fine. But as you can see the difference, it's not meant to be a positive, because when you substitute in a negative here and you square a negative, you get a positive. So we've got one negative and one positive, hence the negative. So important, particularly with squares. And then rearrange to have descending powers of x. A little bit harder, what if we have to substitute in a whole term here? Well, two terms, x plus 2. This is some background work that we're heading towards a concept called composite functions. So it's just a little bit of practice here. Same idea, using brackets. Where you see an x, you're now substituting in a whole expression of x plus 2. Same for the bracket, the squared. So expanding that, here we're essentially multiplying through by negative 1 for each of these. So we would have negative x, take x, take 2. Now here, thinking about how we're going to expand that bracket, expanding a binomial. So keeping in our brackets, we square the first term, square the end term, and then you multiply 2 by x and 2 lots of that. So we're adding on 4x. We'll just check if I'm right. I am, nicely written. And expanding out this bracket with the negative here and collecting like terms. And this is our final answer. Okay, so that's the end of this video on function notation. Give it the thumbs up and subscribe to the channel, and the next video in this series is domain and range, and there'll be 2 videos for that section. Thank you.